Live. So yeah, this is being recorded. Welcome to the Kubernetes Book Club. This is the Friday sessions. We also have Thursday sessions. Thursdays we're doing production Kubernetes. On Fridays we're doing the Acing the CKA. Oh my God, I cannot speak today. Acing the CKA by Chad Crower. Follow the code of conduct from CNCF. Suggest, I think people can suggest your naming attendees, so add them there and then we just approve them. And then the information about the book is there, the link to the book. Also, I put the direct links to the chapters we're going to be talking. So it's the live book if you want to just a direct link on it. I added a dev pod kind of like empty thing, which now I noticed that I'm missing files, so I need to add some other files. I'll fix that in a second. The dev container file, and I'll put you that in a second. If not, then you can use Kind in your computer and follow along. If you have Docker Desktop, that's okay. News, we have 287 book club community members joined. So thank you so far, everyone that have joined. Super happy about the community support. And some news, I don't have a lot of news, just some, if you're submitting talks, CFP is due for GitOpsCon EU that is going to take place in December. CFP deadline is next week. And then the KubeCon for next year in Paris, EU, the deadline is November 26th. I think any more news that people know about?
Today's the last day to submit your CFP for Civo Navigate. Civo Navigate will happen in Austin, which is my hometown, in February of next year.
That's in Texas.
Then I think I can share. How do I sound though? Okay, this time.
Good.
Yeah, cool. And then I can share the KCD Utrecht links. We've just recently released the tickets, and CFPs are also open. Now I'll be putting the link in here.
Good. KCD for where?
Utrecht in the Netherlands.
Okay, great.
It's in December.
Yeah, today's chapter, we think we're going to start with chapter 2. So I'll pass it to Shad, to our host. So I think I'll stop sharing and then chat can start sharing.
All right, thanks, Carlos. Thanks everyone for joining. If you weren't here last week, we just went through chapter 1, talked about the exam a little bit, and just went through some API stuff, and that was about it. So chapter 2, we're starting with the Kubernetes cluster. Let me share my screen. All right, where is it? Yeah, so chapter 2. If you don't have the book pulled up already, you can go to acingthecka.com. That'll direct you to the Manning site. You can click on the cover of the book, and then down at the bottom there's read and live book. That's how I'm viewing the book, and that's how I'll be walking through it for the remaining time that we're meeting here. And chapter 2 is all about the Kubernetes cluster. So this chapter covers the control plane and worker node components in a multi-node cluster and the difference between those two, and then upgrading the control plane components with kubeadm, investigating pod and node networking, backing up and restoring etcd, and then taints and tolerations. So I have, from here on out, we didn't talk about this last week, but at the beginning of each chapter, I've included how this relates to the exam curriculum. So we talked about this last week, but if you just type into Google CKA exam and click on the CNCF link, not the Linux Foundation one, but the CNCF link, and then you scroll down to the very bottom and you go to curriculum overview. You can view the curriculum for each exam, so CKA, CKAD, and CKS, and KCNA and PCA as well. But we're looking at CKA, of course, and so we can pull up basically what's going to be on the exam. What are you going to be tested on? And the book follows this very closely. And so we have this at the beginning of each chapter just to make sure that you're covering all the bases and you're able to follow along with what's going to be on the exam. So for this one, it's a part of the cluster architecture installation and configuration, which is 25% of the exam. And it covers the provision underlying infrastructure and deploy Kubernetes cluster portion, perform a version upgrade on Kubernetes cluster, implement etcd backup and restore, and manage a highly available Kubernetes cluster. So the cluster components. The two main components that you'll see or that you'll come across is the control plane components and the worker node components. So the control plane is the brains of the operation. It controls Kubernetes itself in terms of cluster management and scheduling and the control loop function and all the operations, all the cluster operations. And then etcd is the configuration for the cluster. So that's where the configuration data is stored. So it stores information about how many pods you have running, how many deployments, how many services, all that stuff is stored in the key value store, which is etcd. The control plane components appear as pods in the kube system namespace. And we talked about this last week, but this book heavily follows, all the examples and stuff are following the kind Kubernetes cluster. Kind is a dev cluster that you can spin up similar to Minikube that only requires Docker. Kind stands for Kubernetes and Docker. So very easy to get up and running with minimal requirements. And then we can build multi-node clusters, those clusters being containers, so they appear from Docker as containers. And within those containers, you can actually, run your pods and, containers and containers. It's very, very Inception, that movie that. So anyway, if we go to our terminal, not that one. New applications folder in your home folder. That's weird. I just updated my Mac, so things are strange. All right, so what I like to do, because we're working with kind and it's containers within containers, is I like to exec into the Docker container, which is the control plane. So I do Docker exec. Yeah, I have two clusters. So if I do kind get clusters, you'll see that I have two clusters. One's a single node and one's a two node cluster. If you have questions about spinning up different kinds of clusters, you can refer to the appendix. So in the book, there's Appendix A, which is creating a Kubernetes cluster with kind. So refer to that appendix chapter if you want to play around with that. All right, so yeah, I just exec into the control plane, and then we're good to go. So just like in the screenshot that you see in the book. my Docker daemon's not running. Okay, let me come back to that. As you see in the screenshot here, once we exec into the Docker container, we can use kubectl, which is pre-installed, so you don't have to worry about installing kubectl. Do a kubectl get pods in the kubesystem namespace, and then you'll see we have core DNS, which is DNS within the cluster, etcd, which is the configuration data I just spoke about, kindnet, which is the CNI that Kind uses, the API server, controller manager, and kubeproxy, which is the routing of network packets from pod to pod and node to node. And then we have the schedule. So those are the essential components that usually reside or always reside on the control plane, and then we'll scroll down a little bit here to talk about the worker node and how that's a little bit different. Before we do that, though, let's talk about the upgrading those control plane components, because all these different components, such as core DNS, etcd, kindnet, the API server, controller manager, scheduler, all are installed at a certain version, right? So you may be tasked on the exam with upgrading those components from one version to the next. So here's a example of an exam task that you may come across on the CKA exam. So it says there's a need for company X to upgrade the Kubernetes cluster, Kubernetes controller to version 1.24 or higher due to a bug that affects pod scheduling. Perform the update with minimal downtime and loss of service. So we go through the steps in order to do that. There's a nice little walkthrough here below this exam task that does just that. So first, in order to get what the current version is of each of these components, we can do a kubeadm upgrade plan, and kubeadm will be on the exam as well. So you don't have to worry about installing it. It'll already be there and available for you to use. So kubeadm upgrade plan tells you the current version and then also the target version, which means which version you can upgrade to. Little caveat about that is, even though it says the target version, meaning which version it could be upgraded to, you may have to upgrade kubeadm. For that, I like to refer folks to the documentation, which again you can have open during the exam. So if I go to kubernetes.io/docs and search for kubeadm, and then I click on creating a cluster with kubeadm, which is the first link in the search results, and actually go up on the left-hand side a couple links to installing kubeadm. You can tell I've done this a few times. And then we scroll down to installing the Kubernetes package repository. So we go through the process of adding this to our local apt repository. We can get the GPG key here, and then echo this into our sources. And then once we have that in our sources and a part of our repository, we can just use our package manager apt in this case. There are, so I would stick with Debian for the purposes of this exam. Debian will be the Linux flavor that's used on the exam. So stick with Debian if you can. That's also what Kind uses, so it's pretty easy to stick with that if you're following along with Kind. So we can just do a sudo apt-get install -y, and then kubeadm in this case, since we're upgrading kubeadm in order to upgrade the other controller components. So I'll copy and paste this into the chat so you can have it. And if there's any things that I should be paying attention to in chat, please let me know. Because I'm not watching the I'm not watching the chat because I'm sharing my screen.
No, we're getting some questions, but we're trying to answer them. They're usually around what Kubernetes to use for the exam, so on our local environments, or
Okay.
questions
Yeah, the
related
current
to
version
what
is
to use. Not the
Yeah.
Kubernetes version, but like how to set it up on your local, or should we go for a cloud provider, etc.
okay. My recommendation would be to use kind, and the way you can do that is when you go to create your cluster, you can specify the image to use. So in order to follow along with this chapter, I would suggest using kindest and then node version 1.26.0, so you can upgrade to what will be on the exam, which is 1.27. And you can find this in Docker Hub as well. So kindest / node. So here are all the available versions that you can use with kind. So after you upgrade kubeadm, you can upgrade those control plane components to that version of kubeadm. So even though it says you can now apply the upgrade and execute the following command, kubeadm upgrade apply, you may not be able to do that until the kubeadm is upgraded to that version. I think I may have posted about that in the book club channel as well. That's one of the trivia things last week.
Yep.
All right, let's go a little bit faster because we want to cover chapter 3 as well. So let's. Did you have something? Sorry.
No, just go ahead.
Yeah. So yeah, a little bit more about the control plane. The control plane and worker nodes have different responsibilities, as I described before. Worker nodes carry the application workloads. So most of the time, the control plane will have a taint to it, and we'll get to taints and tolerations in the next section here. But so let's hold that thought for now. Just know that the actual applications that you'll be running in terms of the workloads, the applications that run on Kubernetes, they will more often than not, if there's more than one node in the cluster, will run on the worker node versus the control plane node. I think for obvious reasons, right? Because you want to essentially protect the control plane components and not overload that control plane to which would cause those to fail anyway. So, all right, so core DNS is also a pod that runs in the control plane, but it's considered a plugin. So this is just going over the differences between plugins and what I'm calling system pods. So plugins are like core DNS, like KindNet, which we just looked at, but also there's WeaveNet or Flannel, or a bunch of others that can be used as a container network interface or a CNI. All right, so taints and tolerations. So taints are applied to a node to repel pods. So if you don't want pods to be scheduled to a certain node, you can taint it in order to not have the pod be scheduled. The control plane node is usually most commonly tainted because of what I just described about the control plane components being on that control plane node and kind of that protection mechanism. So usually the control node is tainted with the following: node role.kubernetes.io/master : no schedule. So it's a common key value pair. And we have the, there's tons of combinations of these taints that you can apply, but it's very common to labels or annotations that are used in Kubernetes as well. All right, so here's a kind of depiction of that. So if the pod has no tolerations for that taint, meaning there's a YAML that you can add to your pod YAML to tolerate the taint, meaning tolerate the taint that we just described before. So node role.kubernetes.io/master no schedule. If that matches, then the pod can be scheduled to that node. If not, it's going to repel. This is kind of like a a bounce back kind of depiction there, where the pod is being told to go to a different node. Oh, here we go. So key value and effect. It's not exactly a key value pair, but it's a it can be a combination of key and effect, or value and effect, or anywhere in between. So you'll see that you will see that on the exam. All right. Yeah, so a good example of a taint that's applied to, a toleration that is applied to a pod is in the core DNS pod. Again, the core DNS pod is running in the kube system namespace on the control plane. So we can how the toleration is applied to that pod in order to be scheduled to the control plane. And so this toleration is contains an effect and key that must match exactly the taint that's applied to that node, in this case the control plane. And so we go through an example of creating a pod that has a toleration. So you can get familiar with doing that, because you will most likely come across that on the exam. And so we can quickly get the pod YAML to do so by running the command krun, and then we'll just name this pod tolerate using the nginx image. Dry run equals client. It's something that I encourage you to use a lot in terms of creating that initial scaffolding for your YAML, and then output the YAML to a file named podtolerate.yaml. And once you open that, or in this case cat it out, you can see within the contents, here's what you get: the essential scaffolding, a good starting point to creating that, as opposed to having to sit there and take the time to write each line out, which takes a lot of time, time that you don't have on the exam, because you only have 2 hours to complete the exam. All right, so a little bit more about the dry run flag there, that note. And so if we open this in Vim, which is common text editor, and if you add the toleration with the key dedicated value special user effect no schedule, then we can effectively see that matches exactly with the taint that's applied to the node, and therefore it will be scheduled to that node. I should say it will be available to be scheduled to that node. So it doesn't guarantee that. It's not like a node selector or a or affinity, where you're selecting that node, node. You're rather telling the scheduler that this node is available to be scheduled based on that toleration. So just because you add a toleration doesn't mean that it's going to be scheduled to a specific node. All right, so we added that toleration, and we can create that pod with that toleration with kubectl create or kubectl apply, -f for file, and then specify the file, podtolerate.yaml in this case. When we get the pods and then use the command kubectl get pod or PO for short, -o wide, we can see that in the node column, it was scheduled to the kind worker node, which is what we were after with, or sorry, it's not what we're after. So because they're done explicitly, okay, so yeah, that's exactly what I was just alluding to, is because tolerations don't explicitly, here I'll highlight it, don't explicitly select the node the scheduler should choose. That was scheduled to a node that had more available resources than the control plane. So we will get into node selectors and like purposely scheduling pods to nodes in chapter 4. So hang in there for that. But that was a good. What I was trying to demonstrate there is that just because you add a toleration, doesn't necessarily mean that it will be scheduled to that node. All right, so moving on to labels. So yeah, we'll talk about node selectors and node names in the future, but right now just know that you can apply labels to nodes and then schedule pods based on those labels. All right, so a little bit about how nodes work in the context of kind. So I think I already went through this, but let me know if you have any questions. It's a container within a container, and that's consistent of our Kubernetes cluster, or cluster in this case. So if you do a Docker container ls or Docker ls, you can, or Docker p, you can see that these are Docker containers, and they are representative of our Kubernetes nodes. All right, and I've included a handy dandy, I don't know if you would call this a cheat sheet, but just like a reference guide for the resources that are available in Kubernetes and the abbreviations for those resources. The reason why I included this is because you will want to use the abbreviation as opposed to potentially typoing the name or just having to write the name all out. Particularly with persistent volumes and persistent volume claims, writing persistent volume claim out each time can be pretty exhausting, prone to human error, and cost you a lot of time on the exam. So highly encourage you using these abbreviations, as well as, I think you saw before, using the K alias. So the K alias will be already set for you on the exam, so no worries about having to do that manually. So I would encourage you, along with using the abbreviations, using K instead of kubectl for some time saving there as well.
Persistent volume and persistent volume claim both say PVC. Is that a typo when they get the right column?
Yes, that's a typo. Thank you for catching that.
The top one, I think. Yeah.
Yeah. Okay, I will note that for.
And you added the command. I put the command for folks to know, like API-resources is your friend.
Yeah, kubectl API-resources is the command to see all of the resources, not just these. These are common ones, but there's a full list that you can get by running that command.
And that will give you, let me double check. That will also give you the full version, API version, also kind, and if it's namespace or not namespace. So it's a lot of useful information there in the API-resources.
Oh yeah, that's right. Good point. Yeah, there's some resources that are only available. Oops. Go ahead.
Yeah, I was going to say that that API-resources, I use it a lot, at least when I was starting Kubernetes, because a lot of questions that people have of like, well, how do I know if this thing is cluster, it goes into a namespace or not a namespace, or what is the long version of the name, and then how do I know if there's a V1 versus V1 beta 1, and what is the latest version of it. Some of that you try to Google it, and it's difficult to find that information. But using Kubernetes has a lot of things that people are not aware that are self-documented. Like API resources is one, and I don't know, later you talk about explain. kubectl
Oh yeah,
explain.
I do. Yep, I do mention that.
Okay.
So we'll get to that in a little bit. Just a special mention about CryCTL. CryCTL will CRI-CTL, however you want to pronounce it, is available on the exam as well. This comes in handy for when you maybe can't use the kubectl CLI, or in my case, when I was doing the exam, there was a question about modifying the kube API server YAML in the etc Kubernetes manifest directory, and I did that, and it crashed the API. So when I did kubectl get pods or any kubectl command, it came back with, the API is not available. So what I did to solve that was I ran CryCTL PS, and then saw that the kube API server was not in a running state, and so I deleted it, fixed my change in the API server YAML as well, and then ran CryCTL RM and then the container ID, and so that killed the container, and then it spun back up and was running again. So that's an example of how you can use CryCTL on the exam. All right, so finally, as I mentioned before, there's these components that exist on the worker node. These components will be the same for each node in the cluster, so you can always count on the control plane, kubeproxy, and kubelet being on the control plane, or on the worker nodes rather. And so you can run, for example, you can run kubectl get pods o-wide in all namespaces, which is the -A there in all namespaces, and then grep out the worker just to get a more filtered list there. And then so you have the kindnet and the kubeproxy, which are on the kind worker node, which is the worker node versus the control plane node over here on the, if you scroll to the right. kubeproxy creates our IP tables rules and makes sure that when services are created, we can get to the pods associated with that service. So it's very important to have those on each of the workers, and is also why they exist as a daemon set in Kubernetes. So a daemon set is a resource in Kubernetes where a pod will be running on each node. And so when you add a node to a cluster, a new daemon set pod gets scheduled to that node, and that daemon set will maintain one pod per node, however many nodes there are. So we can grep out the we can run the command kubectl get nodes o-wide again, and grep out containerd to see that the container runtime that's used for this environment or this cluster is containerd, and containerd will also be used on the exam as well. So we're using the same type of components as the exam, which is what we want, right? And then with in terms of the kubelet is, we talked about this last week, but it's the Linux system service, or the daemon, that's available on each node, and you can run systemctl status kubelet to get the status of the kubelet daemon, and then perhaps you will have a situation on the exam where the kubelet service is down or unavailable or inactive for whatever reason, and you must fix it. And so with that, like any other daemon on a Linux system, you can stop, start, restart that kubelet service. All right, and then etcd. So etcd is the cluster configuration data stored in etcd data store. And so that's important, is that on the exam, you'll be asked to back up and or restore the etcd. It'll it'll only, for the exam purposes, it'll only be a one node etcd cluster. etcd can be a cluster as well, so you won't have to worry about working with multiple etcd nodes. And so just picking up that one etcd node will be just fine. In order to interact with the etcd data store, we use etcd CTL, which is a different CTL tool, or a CLI, that will require, because the etcd data store has its own server certificate, will require you to pass the client certificate, the key, and we'll get, so yeah, right here. So
CA.
the certificate, the key, and the CA cert. There we go. That's what I was forgetting. So as you can see here, we go through this in detail in terms of installing installing etcd CTL and setting the API version to 3. That's very important.
Very important.
You will get very different results if you do not do that. And going through the process of running the snapshot save command. In this case, we named the snapshot DB, and then again we pass the certificates to make sure that we have we can authenticate to the etcd data store and therefore take a snapshot. We can see what that snapshot looks like. Doing a snapshot status on the name of the snapshot, and then you can write the output to a table, and so it looks a little bit prettier and tells you the hash, revision, total keys, and total size. So that essentially just lets you know that there's data in there. So if those numbers were 0, that would be concerning because, or that would mean that the snapshot didn't work right. And restoring the etcd data store is, I think, a little bit uncommon, or at least uncommon to the documentation. So I would pay special attention to this in terms of an easy way to restore the etcd data store to that backed up version. So in order to simulate this, go ahead.
Chad, I want to say that in the book, I found it very extremely useful that you gave an actual example of deleting something and then restoring and then double checking with kubectl that object was there. I think it was very, very useful. I think other courses don't do that, of like checking from the kubectl if things are resolved.
Yeah, cool. Thank you. Yeah, I go through the process of deleting the kube system, or the kindnet data store, or daemon set. Let me start over. Delete the daemon set, and then you have something to restore from, right? You have the ability to check your work afterwards, like Carlos just said, so that you know that the etcd data store was successfully restored. So what I like to do is restore that snapshot to another directory besides the current one. So in this case, instead of where the etcd is currently stored, which is in var lib etcd, it's the data directory. I change this from just etcd to etcd-restore. So those two files, for the lack of a better word, those two snapshots exist in parallel, or together in the same directory. And therefore, that allows us to go into the manifest directory where our etcd.yaml exists. So etc kubernetes manifest etcd.yaml, which is on the control plane component, control plane node. And on that note, on the exam, you will be working on a jump host, okay? That jump host is not your control plane. So SSH into the control plane first before going to the etc kubernetes manifest directory. On the jump host, there will be an etc kubernetes manifest directory, but it is not the manifest directory that you're looking for. Can't stress that enough. You want to make sure that you're on the right node and you're looking at the right file.
Interesting.
So yeah, so once we do this, we can find the etcd.yaml manifest and change the host path from etcd to etcd-restore. It's right here. So these files are mounted via volumes in this YAML, and so you can just change the host path. Once you save that file, because it's what we call a static pod, you don't have to run kubectl apply. The scheduler the scheduler is not aware of it. The control plane automatically picks it up and applies that change. So you literally just change the file, save and quit, and
So
it just
let's take a minute here, Chad. I think I have a few questions. So when you say on the control plane, I believe it's the kubelet, right, that is watching these static files. And if there's a change, because sometimes folks, we talk about generics, and then people like, you said the control plane, like that's like 5 things running the control plane, like which one, right? So it's good to understand these minor details. So the kubectl will see that the file change, and then it will delete the pod, right, and give you a new pod with this volume information, because you changed the pod spec, and points to a different folder now. And then when kube API it comes up, now the etcd server, right, has a new folder with a new data in there, and then we just like, you didn't know what happened. So what happens, so my question is, or if you want to discuss it, we can leave it for that later, is what about if you don't do that? What about if you don't use a different directory to restore the backup, and then you clobber the current location while the etcd server is doing read and writes? Is that a good thing? Is that a bad thing? Why?
I think a bad thing, because then you don't have a option to revert your changes, right? So if you overwrite that existing configuration file, then that you won't have any data in your cluster, and so when you run your commands to try to get that information out, try to get that configuration data, it won't be there. So this is why we essentially lift and shift versus replace, right?
Yep.
I just wanted to point out that there's in documentation, there's a explanation of what Carlos just said in terms of the kubelet detecting those files in the manifest directory. And so if you want more detail on that, you can refer to documentation.
And these are pods that in real, like, not part of the exam, but in real life, these are pods that you can, if you have a use case where you're deploying nodes somewhere and you just don't have a kube API server, you just want like deploy a node into a Raspberry Pi or something, and then put kubelet in there, and then you want some pods to always come up in that node to do something, initialization, things like that, or guarantee that it's always there, you can put YAMLs in this folder, right? And then they will come up as normal pods. So that's a common use case.
Yeah, exactly. You can put any YAML files in there, and the kubelet will automatically pick it up.
It could be for security purposes, not saying that people do it for that, or networking snooping, not saying that people do it for that. And yeah, but it's a use case.
Cool. So the last section here is client and server certificates. We kind of went over this last week, so I'm not going to talk too much about it, but this does explain, for one, why we need to pass in the CA cert, the cert and the key to the etcd to be able to take that snapshot or authenticate to it. And so that looks from kind of backing out and looking at the whole cluster and seeing the client certificates and the server certificates. So I just to get a visualization of first of all, the Kubernetes cluster has its own certificate authority, so that's important to know for generating certificates. But also, you're going to need to pass these certificates in order to authenticate to these various components, such as the API, etcd, and yeah, that's it. So
for that, I don't know if you cover it or not, but there's a kubeadm command for certs that you can like check expiration, renew. Like it's a helper for managing those certificate, and it might come, it might not come in some exam. Not saying that I got that question, but I was happy to know that there was a certs command in kubeadm.
okay, cool. Yeah, I don't cover that in the book, so that's good to know.
So yeah, if there's a question around like, hey, this certificate is expired, or check that it's expired, why is something not working? It might be a certificate problem. So you can check with kubeadm certs. What was the command? Check expiration, and then if you want to fix it, then renew those certs.
Cool. All right, so looking at the kubelet.conf, we were just talking about the kubelet and how it's responsible for spinning up pods and making sure that they're running. We can take a look at the kubelet.conf as an example of the kubelet configuration that exists on each node. So notice that the users.
I just noticed I wasn't doing the commands in my cluster. It looks like the CA authority, they expire, I think, 9 years from now. But the other normal, those are CA. The certificate, server certificate, client certificates expire after a year. So what happens after a year? On day number 365.
Yeah, you have to renew those certs or else they expire.
And who's going to remember in your work that you have to do that?
Yeah, usually we would use something like Cert Manager, right?
Yep. And so manage Kubernetes services in cloud, like the cloud provider takes care of that for the kubelet and some other components. For the kubelet, for the majority, like the kubelet is one that is managed.
Okay, cool. Yeah, so the rest of this chapter is just exploring the where those certificates are located and how to just get a feel for mostly the etcd Kubernetes directory, but how that's laid out so you can make those changes accordingly based on the tasks that are given on the exam. And so, speaking of, we can get some exercise by going through these exam exercises at the end of this chapter, which include just that. So setting the alias, getting the output of the pods in the kube system namespace, viewing the client certificate that the kubelet uses, and so on and so forth. So let's go on to chapter 3 just for the sake of time, and we'll go through the identity and access management. So in this chapter, we cover the basics of RBAC. RBAC stands for role-based access control, and is how you will authenticate to the cluster and will assign certain roles or cluster roles to certain users, groups, or service accounts. We go through creating roles and role bindings, using certificates to create users and groups. So this is a fun, and you may not necessarily have to create on the exam, but I think it's a fun exercise just to get a feel for creating a user and certificate and kind of generating a kube config in order to authenticate to the cluster from a new user. And when I say user, I mean just a kind of a figure of speech. It's just the common name that's used in the certificate. So it's not, there's no user database or any kind of IAM in Kubernetes. And so These are just kind of made-up names or groups that exist as in Kubernetes.
So what are groups?
Yeah, groups are a way to apply permissions to a set of users. So you can create a user, have that user be associated with a certain group, and that makes it easier to apply the rights to view resources, update, delete certain resources in Kubernetes.
So how do you add a user to a group? If I'm a Linux person and I know like etcd groups and etcd pass wd, that's how I do users and groups. How would I would do that in Kubernetes?
Yeah, so I will show you. So first, let's just get down to that point. So again, just a note about the exam curriculum. So in this chapter, we cover the still on the architecture, installation, and configuration domain, but this time we're going to cover the RBAC and highly available Kubernetes clusters. So if we scroll down to the role-based access control, and an example of using role-based access control is when we use the kubectl CLI. It's essentially authenticating us to the cluster so that we effectively use this kubeconfig to gain access to the cluster, to be able to view pods, create pods, any resource, create services, secrets, config maps, etc. And so we can create, go through the process of creating a new role. So create, kubectl create role is the command. Just a simple note about that. If you forget all this stuff and just do kubectl create role and then a -h, that'll pull up the help menu. And in the help menu are examples, example commands. So you can literally just copy and paste from the help menu and then modify, the verb or resource, and then you can quickly get your role up and running from there.
I think that's something that I think a lot of people don't know. I think they get lost of the valuable thing of the kubectl, like kubectl, kubectl, -h. I want to say every, if not almost every command in kubectl that you will have a help command at the top. Like sometimes people don't look, but if you scroll back to the top, at the bottom when you get all the flags. But if you scroll up in there will be around like 6 or 7 like useful, most common examples. And this is not for just for the exam, like at work, like every day when you're working with kubectl, what you want to do, the answer will be there, like almost enough information in there that you know what you need to do, and then you waste less time like looking around or asking people. Like the answer is there in -h. And also for the exam, very quickly you have more confidence when you go to a CKA exam to know like, oh, if I need to do something related to this, I just do -h, and then there's things in there that will help you. And if you want to do it faster, then please set up auto completion, right? Because then you start passing the flags, the beginning of the flags, and then you can tap tab, and then auto completion like helps you the long, for example, long flags, like from literal, right? When you're creating a secret and things like that, or from file.
Yeah, help menu is your friend. All right, so the how we authenticate normally and on the exam is just basic HTTP authentication, but there's other ways of authenticating to the cluster, such as a static token file or a third-party identity service, such as AWS IAM.
Sorry.
Just goes over that. And yeah, so when you make a request to the API, all plugins analyze the request and try to determine if they can read it in sequence. There's just additional detail on that. The important part to gather out of these 3 paragraphs here is that there is a certain process that the API goes through to authenticate you, whatever plugin you're using, and then you gain access based on that.
Yeah, the API server, what cares is you give me a valid cert at the end for that connection, that HTTP request you're doing.
Yep.
And if you want to learn more, I just want another tip. If you want to learn more about the interaction between kubectl and the API server, something that I did when I was getting started was verbose logging. So that you can do dash, is it L, Chad? Dash L or dash log level? One of the two. Or dash V. I think it's dash V.
Dash V, yeah.
6 or 10. If you are here and you're a programmer and you're like wondering like what are these interactions between the CLI and the kube server, you will see actually in there the payload of the headers, the body, and everything on that interaction of like the request sending and the request coming, the response, the request and the response. And that's very useful when you get to the level of like trying to understand how you communicate to the kube API server, and if you are like writing programs or something that you need to connect to it programmatically. Like we had the session on kubebuilder, right? We're building controllers, and it's the same thing.
Yeah. So service accounts, speaking of programmatically, service accounts offer pods the ability to access the Kubernetes API programmatically. Service accounts mount the token, and the recent change to that is that it doesn't create a secret per se, it doesn't create a secret with the service account. It just it's mounted using a different mechanism. So just be mindful, I guess, if you're used to describing your services and seeing a secret there, that no longer appears. So disregard this mention of that in this diagram. So after the authentication phase, the request is passed to the authorization plugin. So once you've been authenticated to the cluster, meaning you've gained initial entry into the cluster, you then get passed on to the authorization plugin, which determines what you can and cannot do in the cluster. So this is the permission to view pods but not delete them, or the permission to create secrets, delete secrets, whatever resource, create deployments, config mats, secrets, anything. So authentication is your permission to do that or not to do that. Special mention of the authorization mode, which you can modify the authorization mode if you want in the Kube API server YAML, which is again in the etc Kubernetes manifest directory. So if you see here under commands, we have authorization mode, and then for this one, it's node and RBAC. On the exam, one of those may be missing, or you may need to add an additional authorization mode. So just be mindful of that. If you get a test like that on the exam, this immediately should trigger in your mind that you should refer to this manifest. All right, so roles and role bindings. This is, once you create a role or a cluster role, this is what allows you to bind that role to an associated subject. So that subject being a user, group, or service account. And so you must have a role with a that's attached to a role binding, or you can have a role to a cluster. Actually, I have that depicted down here. Let me just fast forward. Okay, so you can have a role binding is attached to a role. You can have a role binding that's attached to a role. You can have a cluster role binding that's attached to a cluster role, but you cannot have a cluster role binding that's attached to a role. So the reason why I mention this, and it may be obvious, but you don't want to bind stuff that's associated at the cluster level with roles, meaning the actions that you can take that are only at the namespace level. So there's you can go one way but not the other. All right, let me rewind to that other diagram. And so we create these roles, which are namespace. Cluster roles are cluster-wide to pertain to these specific verbs and attach those verbs to the subject. A quick little reference here in terms of getting familiar with the request verbs. So if you're familiar with HTTP verbs, it's very similar. You can draw a correlation to post, get, put, patch, delete, which equates to the request verb create, get, list, watch, update, patch, and delete. So those are how you can kind of formulate, like based on the task on the CKA exam, which one you'll have to select as far as the request verb is concerned. So on the exam, if it says, create a cluster role that you can only get persistent volumes, you'll want to use the request verb get, list, or watch in this case.
Hi, Chad. I think we are a little bit over. We can finish this. We can continue next week. I just want to be mindful of folks. If there
Yeah,
were any
absolutely.
disagreements on that. I want to say something about this of the get, list, and watch. I don't know if it's an exam or not. I'm trying to remember when it came up, but the misconception that if you don't give, for example, get access to a secret, like for example, you select list but not guest. I'm going to give you permissions to list the secrets but not get. People have the misconception of thinking that list will give you just the names of the secret but not the content, and that's not true. List will actually give you the list of the secret names but also the content. So if you want to protect something with a role that they don't have to have access to certain information, usually secrets, right? Don't make the mistake of just giving list but not get, because you're actually giving all the information with list. So you have to prevent both get, list. I think watch is only the names, I believe.
That's right.
Okay. Well, folks, sorry to interrupt, but want to be mindful of the time. I know people have other things, and also Chad's time. Like he's been talking here for 1 hour, so anyone that have done this, get a little bit tired. We took some notes, but hopefully you can join. I don't know, put an emoji. You like the session and you're planning to come next week, and we'll continue in the identity, right? Because finish identity can start maybe the other one. So we'll continue as I don't think there's a hurry for this. If there's questions, we'll answer them. If there's no question, we just continue, right? So this is a study sessions, and I'm super happy to have the book author here to actually explain the book. So thank you, folks, and tell your friends if you're planning to take the CKA exam, and if you planning to take it, take some of the coupon codes that we're sharing and schedule it. Like just schedule it, because sometimes you can schedule ahead of time. You wait for the last minute, there might not be slots available. So just schedule it for a day that is convenient for you. It could be a weekend or something like that, or during after work. And then I think you have like a day before, 2 days before. If you cannot make it, you can reschedule it again, like for later. But if you put it on the calendar, then you feel more better of like taking it. So any last word, Savvy, Chad?
Looks like Sevi's mic's not working, but yeah, thanks everyone for coming. Appreciate your time, and yeah, reach out in the Kubernetes book club channel in CNCF Slack, and we'll talk to you next time.
Yeah, get those kind clusters up and start playing with it. Okay, see you, folks.
Thanks everyone. Have a good weekend.